In this video, we are going to talk about very commonly used terms in the quantum world. I'm Naresh Jasatani, and I am a specialist customer engineer working at Google in AI and ML space. I'm going to be a presenter for this course. I have published Adapting TensorFlow for Real-World AI, which is available on Google Play Store as well as Amazon Kindle. In the previous video, we talked about what is a quantum circuit. Let's take a look at it again. A quantum circuit is basically a diagram which shows how to do a quantum computation. You have qubits laid out in time axis format. So how you read this is top to down, top to bottom, and then left to right. So these boxes are quantum gates, basically computing gates, logical gates. Qubits, as we discussed earlier, are bits in the quantum world. A qubit can take a value of 0 and 1 at the same time. Please refer to my previous video, which is what is quantum computing, the link to which is mentioned in the video description section of this video. So let's look at, and I discussed last time as well, that you can perform operations on the gates together at the same time in a correlation fashion. So what are the terms used in quantum computing? Let's look at those. Quantum. The word refers to the discrete quantities of energy or some other physical quantity. As I discussed earlier as well, where quantum computing is driven by quantum mechanics, which is physics at an atomic and subatomic levels, where matter, energy, and momentum, all three, matter, energy, and momentum, are quantized. Unlike classical computers that are based on sequential information processing, quantum computing makes use of three fundamental properties of quantum physics, which is superposition, inferences, and entanglement. Entanglement is a correlation between two quantum particles, and we are going to discuss a few more terms now. Qubit is a bit in quantum world, which is known as quantum bit or qubit. In a classical computing, think of a bit which can take a value either 1 or 0 at a time, but in quantum bits, as you have seen earlier, it can have both 1 and 0 at the same time. The number of classical bits, B, required to represent a qubit is 2 raised to the power of qubits. For a Sycamore processor, you would have 54 qubits. That means the number of bits required would be 2 raised to 54. Superposition is a special mixture of energy levels 0 and 1, where the weights of each energy level is given by complex constants C0 and C1, and so forth. I would strongly recommend to look at what is quantum computing introduction. Video description below has the link to that video. Measurement is a step which turns the qubits, the quantum bits, to classical bits. Quantum gates are instructions to send control signals to the quantum computing to perform certain actions utilizing qubits. So quantum gates, in the previous diagram you saw the boxes, those were the gates, and those are logical control signals, instructions to perform certain actions. Quantum circuits is the model, which is a diagram you saw earlier on how to perform a quantum computation. And a quantum computer is a computer which stores and acts on the information based on the quantum circuit. NISQ is an era. Now, today's scientists are very smart, smarter than the scientists earlier. I can say that arguably. So they defined this initiation, the embryonic phase of quantum computing era, as NISQ era, which is noisy intermediate scale quantum. it is going to distinguish the future error-corrected quantum computers, and therefore the era is known as the NISQ era. Now, how do I do quantum computing? How can you get access to quantum computers and start working on it? And for that, you would use TensorFlow, quantum computing. This is one of the methods. There are other methods as well. TensorFlow Quantum is a Python framework for quantum machine learning. TFQ, which is TensorFlow Quantum, allows quantum algorithms and researchers to leverage Google's quantum computing framework within TensorFlow. So imagine the power of machine learning with quantum computing. You will be in a different phase. I understand that the TensorFlow and quantum computing together gives you a different level of complexity. And that is where these series of videos are going to help you understand that quantum computing on TensorFlow. Cirq is an open source Python framework by Google, and in the future videos, in the next few videos, I'm going to talk about Cirq, and we'll use Cirq for TensorFlow quantum computing. TensorFlow Quantum implements the components needed to integrate TensorFlow with quantum computing hardware. You will not see a quantum processor, but you will be able to perform operations on those quantum processors. So how would you get access to quantum computers? This is done by Google Collab. I'm going to show how you can access quantum computers on Google Collab, which is a free cloud service that supports GPUs, which is graphics processing unit, and TPU, which is tensor processing unit. You can write your Python programs, and it supports TensorFlow, which has this package Cirq, and we will work together to learn quantum computing. How to access Google Colab? This is a link. In the next video, we are going to learn quantum computing using TensorFlow. Thank you for watching.